bonding new concrete to old concrete. Oh boy, I made a video on this a little while back and it got a few million views and 50,000 likes and some 1,500 comments, and it's actually a really great video. It covers a ton about how to bond new concrete to old concrete, and it does it in a very fast and repetitious way so that you can learn a lot of it very quickly. But you know what? You can learn more about this process, bonding new concrete to old concrete, and I'm going to teach it to you in this video here. I'm not going to be pressed for time here. I'm not going to try to like cram this in under 5 minutes, because there's actually a little bit to unpack, because there's a bunch of questions along the way. That's why there was 1,500 questions on that, or comments on that video, because there were things which were unclear, or there's different situations which could apply, and that's what this video is about. I'm going to teach you all of that, everything that was covered in the last video, a bunch more that wasn't covered in that last video, and then we're going to just go ahead and do that process together on a problem area of concrete. So there's the problem area of concrete there, and the reason why I've chosen this area in specific is because it has a bunch of common problems that people are going to encounter. Like, this isn't just like some concrete that kind of failed and broke away. Like, it is, but it isn't. First of all, this is very old concrete, more than 40 years old. So I have to bond new concrete to very old concrete. That's the first challenge. The next challenge, or set of challenges, are this is salt damaged. This is also chemical damaged concrete. This concrete is also saturated with oil, years of oil saturation. It's filthy, it's dirty, it's dusty, it's spalling. This is just a worst case scenario for some crappy old concrete. And we want to bond some new concrete on here, make a concrete patch, and we want it to last. We can definitely do that. I'm going to show you the entire process from beginning to end. Let's get started right now. Okay, we need to stop. We've already encountered a problem, so we have to address this. Take a look at this concrete area here. I can see an area where it's cracked. I don't know if the camera's picking up on it, but let's go ahead and sound this area. And before I do that, let me explain what sounding is. So you take your hammer, something heavy would work. It'd be good if it's relatively blunt, and just draw it over the surface of the concrete that you're looking to patch. And if there's any areas which are cracked or delaminated, like, just because you can't move that concrete piece out with your finger doesn't mean it isn't actually broken and failed. And if it's broken and failed, we got to get that out of there. We can't patch over rubble. Like, anything that's loose or broken has to go. In the process of finding it is called sounding, and it's with a hammer, just drawn over the surface, listening for the hollow spot. It will sound obviously hollow. Let's take a listen here and see if we can hear it on this patch. Okay, so listen. Okay, so depending on how much concrete you need to remove, you could use, just a hammer like this to just lightly tap out the broken area. You could break out a chipping hammer, which is like a small jackhammer product, to clean up the loose areas. It's ideal if you can make the patch not feather edge. If you need to zero out your concrete, which is to say it's going to reduce in thickness to zero, that zeroed edge will fail. You need at least some thickness. Like, it would be good to have 1/8 of an inch, 1/4 of an inch. And this requires a heavily modified mix in order to do that. If you just used a regular concrete mix 1/8 of an inch thick, it's not going to work. Like, if you read the bag of a regular concrete mix, it tells you like 1.5 inches thick is your minimum thickness. So we're asking a lot from a concrete mix to take it down to a feathered edge here. But if we modify it, make it stronger, and then do what we can to eliminate that zero edge, that will go a long way towards this patch lasting. In the last video, I jumped right to acid washing, because for the most part, acid washing is what people do. But you know what? You can't clean concrete with acid yet if it's saturated with oil. If you have something like what I have here, which is like a shop floor that has years of oil saturation into this concrete, If you acid wash immediately before degreasing, what you're going to do is you're going to bake those acids right into the concrete. Now they're not really going to emulsify when we go to remove them. So it would be a very good idea to do a degreasing process to this old concrete as part of our cleaning and preparation for adding new concrete to this old concrete. There are a couple of commercial degreasers that you could use, even some household products. My favorite one to use if I had everything available to me would probably be TSP, trisodium phosphate. And this product, when mixed at a quantity of 10:1, so 1 cup of these granules and 10 cups of water, and mix that together and apply that to your old, dirty, oil-soaked concrete. The TSP product is a heavy-duty degreaser. It will emulsify oils, and it will also do a good job of saturating into the concrete, going down below the surface layer into the subsurface layers where these oils are, and helping to pull and leach them out. So it would be a really good idea here to do a degreasing process. You don't have to use TSP. There are other options. I guess maybe the easiest and most common option, everyone's going to have it, some kind of dish soap. Dish soap is a degreaser. So you could do that. And you might even still, like, if it was a really bad situation. But for me, I would just stick with one degreaser product as opposed to mixing and matching. I'll give you another household example of a degreaser. You could use granular dishwasher detergent dissolved in water. Basically at the same concentration that you're using this granular TSP, which would be 1 cup of TSP or 1 cup of granular dishwasher detergent to 10 cups of water. There are other chemical-based degreaser products that I don't prefer to use. I don't want to introduce chemicals where they don't need to be, because this could add to, compatibility issues with future products or that I might be using in my concrete mix, or a paint product that I want to apply at a later point. So I tend to stay away from adding chemicals where they're not needed when I can use simple degreasing methods like this. When you apply the TSP rinse to the concrete, I want to start with it already wet. So basically I'm going to rinse the whole area first, and then I'm going to scrub it with TSP. So we've done our degreasing with trisodium phosphate. If you had just the worst case of grease or oil soaked concrete, and so much so that the TSP is not even touching the problem, the only other place that you can go from there would be to use Varsol or a turpentine product, and that would be an emulsifier. It's a thin liquid which will absorb into the surface, and it will break down the oils, and then you would put like a kitty litter or sawdust on top of that to help pull all of that Varsol or turpentine back out of the concrete before you proceed with the patch repair. I would rather do 3 applications of TSP before I did an application of Varsol or any kind of paint thinner. So that's just the way that I pursue it. But sometimes it can be bad enough that you just simply can't get there with a TSP or a home-based degreaser like dish soap or automatic dishwasher detergent. Okay, so now that we've degreased this thing, we can actually start the cleaning process. And the cleaning process for old concrete is acid wash. So that product there is muriatic acid. It's sold at most hardware stores, or it used to be, it still might be. It's sold at most pool and spa stores. It's commonly used to lower the pH in swimming pools. It's also used as a concrete cleaning agent. You can use it in a very, very dilute concentration, like 50:1, 50 parts water with 1 part of acid, and you could use that to like clean something very lightly. But when you're talking about cleaning concrete to prepare it for new concrete to bond, it's not really cleaning. That's not really what we're doing here. We're actually doing something more. What we're doing is we're exposing the concrete. What the acid does in a stronger concentration will burn away the Portland cement, which is exposed, also impurities like efflorescence and things like that, and it'll help to remove those from the concrete surface, exposing a fresh, new, porous and clean concrete surface that we can apply our new concrete over. When I'm doing an acid wash, I find one of the most convenient methods to do so would be from a plastic garden sprinkle can. And the mix ratio that I tend to use would be somewhere in the range of 7 parts water and 1 part acid. That's kind of like on the stronger end. And then on the weaker end of my spectrum would be 10 parts water and 1 part acid. So that's kind of the spectrum that I aim for. And oftentimes, if I'm aiming for that, even just an approximate measurement that gets me into that range would be acceptable for a concrete cleaning application. You also want to remember that when you're making your acid mix, this is critically important. You need to add the acid to the water. You never add water to the acid. And if you're not sure what I mean there, quite simply, if I'm going to make the mix right now, the first thing I do is I fill up my container with the amount of water that I'm going to use. So now I have the amount of water that I'm going to use in the container, and now I add the amount of acid that I need to that water. I never do it in the reverse direction there, where I add the acid to the container first, and then I add my water to that. You never do that when you're making an acid wash. What you're going to see here when you apply even this diluted acid wash is you will get bubbling and hissing and that is the acid doing its job, eating away those Portland cement, that Portland cement residual layer on the surface and exposing a clean layer for us to bond our new concrete to. It's very important when you're working with any kind of acid like this product. You would want to wear a cartridge ventilator, and you would want to protect yourself with like long clothing and gloves, things like that. In addition to allowing the acid wash some time to do its thing, not like half an hour or anything like that, but like a few minutes would be a good amount of time to leave this acid wash on the old concrete doing its thing. During this process, I might be inclined with very old and dirty concrete to take a stiff nylon brush and then use that to scour and clean the area. But do be careful. You should be wearing protection, because doing something like this is going to cause the acid wash to splatter and get it, splashed around. And you definitely don't want to get any of that on your face or eyes or exposed skin, anything like that. Once we have completed the acid wash, the first thing you should do is you should neutralize this acid. Right now, this is the pH of this water that we're dealing with is very, very acidic, like basically dangerously acidic. So we need to add something alkaline here. A great option would be baking soda. Sprinkle some baking soda over the area, give that 1 minute to do its thing, and then rinse the entire area clean. TSP that we were working with earlier is actually another great option here. You can use that to neutralize acid because it is a very high pH. The pH of TSP is somewhere in the range of 12. So using some TSP as a rinse after you've done the acid wash would be a great idea here. Not only do we want to neutralize that runoff water from doing the acid wash, we also want to neutralize the concrete itself that we're going to be bonding new concrete to. This is very, very important. If you were to leave that concrete unneutralized, what you would have is a very acidic environment, and the very alkaline concrete mix that we're about to add to that is not going to like that at all, and that can definitely lead to a bond failure between the layers. So it's very important to neutralize the old concrete area after you have completed the acid wash. So we degreased this thing, we acid washed, we've neutralized that area. Go ahead and give it another rinse again. You can't wash this thing clean enough. Okay, now that we've got this old concrete prepared suitably to receive a patch with some expectation of success and longevity, we need to go ahead and we need to mix ourselves a bonding slurry. A bonding slurry is something that we could make it of a couple of different things. I'll describe all the ways in which you can make a bonding slurry. We're going to be using Portland cement, type normal or type general use Portland cement, not masonry cement. If it's masonry cement, it's the wrong thing. Portland cement is what you need. Type normal or type GU for general use. Now we could make a bonding slurry just Portland cement and water. I'll go get some cement right now and we'll just make that up. Okay, so here we have our Portland cement. And as I mentioned, we could just mix this with water to a consistency that is something like almost melted butter. That would be the best way for me to describe it to you. I saw other people describe it as pancake batter. So if you were to mix some Portland cement and water until you get the consistency of pancake batter, then you have yourself a bonding slurry. Basically what's happening here is the very high cement ratio here is going to create a lot of bond between the layers. Further, the cement is dissolved in the water, and so it will seep into the existing concrete and thus create kind of this like matrix for additional strength. So it does a good job with the bonding, but it could do a better job here if we introduce an additional product to this pancake batter of cement and water. There's two main options that you need to know about. So, Weld Bond, that's just a brand name. And this was one of the biggest comments from the last video. This product is PVA, polyvinyl acetate. It's white glue. That's what's in here. Now, Weld Bond is a proprietary version of this white glue, and it's augmented slightly to have better longevity for this application. But you should be aware. Basically, it comes down to this. This product and any PVA-based product, which is the thick glue, white glue, it can fail when exposed to water. So what it comes down to is whatever concrete you're bonding, is this like inside concrete or is this like outside concrete, right? Is it going to be dry consistently for its life, or is it going to be getting wet and dry and wet and dry and wet and dry forever? If it's going to be dry consistently, PVA is the product that we add to our bonding slurry. If it's going to be exposed to water, you would use an acrylic or latex product. So acrylic or latex is thin, like milk, and this product can be added at the same ratio as the PVA product. And so that ratio is, for a slurry, approximately 50% of the liquid content that you use to make the slurry can be from the bonding product, either the PVA or the acrylic product. I find that more often than not, I reach to acrylic. This is the one that I like to use, latex or acrylic. First of all, it's thin. It helps to make the slurry. Second of all, it works for any kind of wet application. And it also works if it's dry. It's not like this one that stops working when it's wet. This one also works when it's dry, so maybe just reach for that one to begin with. I'll address another question. A lot of people commented, some people who are somewhat knowledgeable about concrete, oh, just use SBR latex, styrene butydyl latex, something like that. And it's a form of this product here. And it is the form of this product which has the most aggressive bonding characteristics. But you know what else it has? It has a real problem with sunlight or UV. That product is what you use when you're going to cover that area with something mechanical to protect it from the sun, basically, right? So if you use an SBR latex product as your bonding bonding additive here to our slurry, what ends up happening is that if it's exposed to the sun long term, it fails. It's kind of like what a rubber band does when you leave it out in the sun, right? It used to be all stretchy and whatever, leave it out in the sun for a while and you pick it up and it's all cracked and broken and fissured and you go to pull and there's no stretch at all, it just fails, right? So that's what SBR latex does when exposed to UV. That's why you would find that product in something like a thin set mortar used for setting tile because it works like crazy for bonding, but it needs mechanical cover. You can't just leave that exposed in the mix. So that's why something like this, this slurry, I prefer not to use an SBR latex, though there is a time and a place absolutely because it's fantastic. But the acrylic or latex product I find does the most consistently good job. It's available at absolutely every hardware store, so it's easy to find. Everyone can do it. And about 50% of the liquid content that you make your slurry with is going to be with this product. I find the easy way to do that is I'll just get some water, like a 500 milliliter bottle of water, pour half of that water out, and then just refill it with this, and then make my slurry out of that. Now I have a pre-mixed product, which is the exact ratio I need for the liquid, and then I just pour in the amount of liquid I need until I achieve that warm butter / pancake batter consistency. I guess we could just touch on making a repair mortar for a second here. It's not the intention of this video, but if you're wondering what would be a good mix to use to make a repair mortar, I would use 2 parts sharp sand, 1 part type normal Portland cement. That is a high cement concentration for the mix, but the sand is going to give you a good amount of strength because the glue is the binder, but we need something to bind, and 2 to 1 is going to give us a really strong end result with a high concentration of cement, which does enhance the mechanical bond between the layers. So I have the repair mix. I have the area prepped and ready to go. Wait, before we proceed, we need to talk about SSD. Saturated surface dry conditions. That's exactly what we need here. Before we get ready to apply our new concrete to our old concrete, the last thing we're going to do is go ahead and rinse that whole area down again. Soak it until it can't absorb any more water. Now, we don't want pooling water on the surface. That's why it's called saturated surface dry. So go ahead and use a shop vac or a sponge and blot up any standing or pooling water that's left on the surface. As soon as you finish doing that, we are ready to go. Using a paintbrush or a masonry brush will be your 2 best options here for applying your slurry to the old concrete area. Before you do that, go ahead and dunk these things in water, and then go ahead and dunk them in your slurry, and we can start pasting them into the old area. Okay, so we're going to paste this slurry in and go ahead and be generous with it. You don't want it to be thick, but you definitely want to have sufficient coverage everywhere. And this brings us to the single most asked question. After millions of views on the last video, here is your answer. It is critically important that you apply your repair mortar to this old concrete area before the slurry dries. If the slurry dries, this is not going to bond. It's that you're actually creating a bad situation for a bond by using the slurry if you were to let it dry before you add your new concrete over top. So you add your slurry layer before it dries or skins over, you now add your repair mortar on top. If your slurry dries or skins over, just dunk your brush into the slurry mixture again and go ahead and paste some more into there. And now you can go ahead and add the new concrete over the old concrete. When you add the new concrete over the old concrete here, you want to level it flat. You could call it troweling, but really what you're doing is floating it. You're just kind of getting a basic shape right now. Do not try to get a finish on the surface. At this point, you're not trying to finish the concrete. You're just trying to place it and level it. Once you've placed and leveled the repair mortar onto the old concrete area, what you want to do now is just wait. The amount of time you need to wait will depend on how hot it is, whether there's sun on the area, the amount of calcium hardness in the water that you use. There's a lot going on here that could affect how quickly your concrete repair mix will start to actuate. But all you need to do is look for this. When you place and initially level your concrete repair, it looks wet and glossy. When it no longer looks wet and glossy, but it appears to be matte or hazy, that is the time in which you can get the best finish on the concrete. Now, there's a bunch of different ways that you can put a finish on concrete. You could do a smooth steel trowel finish for a very slick, smooth surface. You could do that same process, but then draw a broom over top of that to put a broomed texture in. I find that when I'm matching with an old concrete surface, one of the most effective techniques is simply using a wet sponge. A wet sponge will allow me to marry the new concrete to the old concrete in a very effective way, and it also somewhat mimics the texture of very old concrete. So that way I don't have such a standout obvious repair area. Like, it will definitely stand out. You will certainly be able to see the repair area, but at least the textures are going to match overall. Using a circular swirling pattern is probably the best method overall with the damp sponge to marry the edges of your new concrete patch to the old concrete area. You have to remember that any zeroed edge here is probably going to fail, so you just do what you can to minimize that and accept that this is a repair, and down the road there will likely be some cracking that you experience along the edge of your patch where the new concrete meets the old concrete. Usually it wouldn't be a problematic amount of cracking. If it ended up being a problematic amount of cracking for your repair, a concrete urethane product would be the proper product to use to help fix that crack. Looks good. It's only been 12 hours here. That's a good patch right there. What I would normally do is take something like a scraper or some 220 grit sandpaper, and I would sand that smooth or just scrape it smooth. When you finish with a wet sponge like that, it's obviously not a good concrete finish, but the rest of this floor is just a disaster. So, if you made it smooth, it would really stand out like a sore thumb. But I would not scrape this down, and I would not sand this down yet. It's only been 12 hours. You really need about 72 hours for this to set up. Like, it's hard, but not really. It's really only just starting to strengthen up here. After 12 hours, it's pretty warm in here, so it is like appreciably hard. You could walk on it, that kind of thing, no problem. But I wouldn't scrape and sand it until you get just a little bit more strength here, because you want to kind of shear the grains of sand as you scrape or sand. But right now the Portland cement is still weak and it'll just release all that. So really all we do at this point for 3 days is we keep it wet. And that's it. We've made a patch that's gonna last. And there we have it. We have managed to bond new concrete to old concrete. That was just the worst case scenario in terms of all the problems the old concrete had, and this has a very high likelihood of success and longevity. I hope you found this information helpful. If you did, remember, I'm technically Steve, so it will technically help you if you like this video and subscribe to this YouTube channel. And if you do, I'll see you soon.